So we're going to be talking about the binomial radical expression notes. So the first thing you need to remember is like radicals. Like radicals mean they have the same exact index number and the same exact radical part, which just means your radicand. Again, that's important. The index and the radical part, which is your radicand, must be the same in order for them to be like terms. So if they are like terms, then what you can do is you can add the coefficients. Remember, the coefficients just mean the numbers in front of your variable or your radical part. And the same thing can be said for the subtraction. If they are like terms, then you're just going to subtract the coefficient and keep the radical part. Again, they have to have the same index and the same uh, radicand. So let's talk about a couple of examples. So if you look at the first one, for my first example, we need to simplify each expression. If you notice, they both are 5x is the radicand. If you notice, also they both have, they're both square roots. So all we're going to do is go 3 minus 2, which gives us 1. So that's the square root of 5x. Now, another way to write that, if you want to actually have some sort of number in front, you can actually write it as 1 radical 5x. So again, you can leave it as the square root of 5x or 1 square root 5x. It's up to you. For state purposes, state testing, you're not ever going to really see that 1 in front. You're always going to see just the radical 5 when there's a 1 in front of it, a radical whatever's inside. That's just how it goes. So now for this one, if you notice, they have the same index, but the inside part, which is my radicand, is not the same. So I cannot do anything with it. So you notice one is 7, one is 5. They're not the same. Also, just to take note, this one has a exponent number of 2x, and the 4 has a 1 as the exponent number. So that's also not the same. So this is simplified. This is as small as it can go. So again, it's already simplified, and the reason for that is because the radicands are not the same, and also my exponent numbers are not the same. So when we say already simplified, that means you can't do anything else. The next one, if you notice, my index for number 3 are not the same. One is a 5 and one is a 3. Since they are not the same, it's already simplified. So again, they have to have the same index in order to be able to add or subtract the coefficients. So again, different index numbers already simplified. So make sure you state that so that you know. So now you all try the next 6 where it says try now and see how you come up with it and if you understand it. If you have any questions, let me know. All right, so now what are the simplest forms? If you notice, which we've done this before, we're adding radicals, but if you notice, they're not the same radical parts. So we need to reduce them. So I'm going to reduce and break it down the way I feel like it. You could use other numbers. You don't have to necessarily do the ones that I do. So anyway, you break it down. Square root of 4 is 2. And then you have the square root of 3. So that's how you do the first one. Again, because you break it down, well, for me, I broke it down 4 and 3. Square root of 4. For here, I did 3 and 5. The square root of 25 is 5. So again, I did 3 and 25. The square root of 25 is 5. And then my radical 3 stays there the way it is because it does not have, I guess, another pair or partner or whatever you want to call it. And then you have your radical 3. So now that equals 6 radical 3. And the reason for that is because I added 2 plus 5, which gave me 7. 7 minus the 1 that's there, because there's a 1 that's written or assumed it's written there. So again, you add your coefficients, the numbers in front. So I added 2 plus 5, and then I subtracted my 1, and that's how I got 6. Because this would have been 7 minus 1, which gave me 6. This is my final answer. 6 radical 3. If you have any questions, let me know. Now you all try the next one and see if you understand how to do it. If you have any questions, let me know. Again, make sure you remember for this, you're doing your index is 3. So you need 3 of the same in order to take out a number. So you're taking out a group of 3 for each one. If you have any questions, let me know.